Hi. Oh, the bell may ring at any second and I can't pause. But anyway, so I'll just stop talking while it rings and you could fast forward. I'm going to go over 6.3 today, n through and rational exponents. So roots in this case, we're talking about the radical symbol. And here's a great demonstration of the vocabulary. Um, So, but right here, exponential or radical form. Exponential is an exponent, and radical form is this. And you're going to learn the equivalent of this would be exponential form, radical form. These two are equivalent, and I'll go into more of that. Okay, so here is a picture which is great for the definitions. Index is this little number here. So usually when we take the square root, we don't say square, okay? Plus or minus 3 is always usually accompanied by the root of a number, especially with the square. We don't put a 2. I think iPhone calculators may put a 2, but you never really, that's not standard. So the index is the number there. Radical symbol is the actual symbol. Radicand is the number inside. Now, principal root, although I'm not sure you really see this again, is the square root of 16. The principal root is 4 because it's plus or minus 4, so the non-negative answer. And go to the next page. Okay, so finding roots. Now, you should put a square around this. This is a plus and minus thing, but right there, square root of 25 is 5. So if I take the square root of 25, the radical symbol goes away because it's the square root of 5 squared, and the radical symbol cancels. So there's no more radical symbol. I saw a few people have radical symbols in their answers. No, you're getting rid of the symbol. I want to show you here before we go on what the radical symbol does to a power, an exponent. So here, if I have 5 to the 1/3, I don't know if you remember, I don't remember which lesson I said, that's the cube root of 5. Now, how are these connected? 5 has an exponent that we don't write of 1. So it's always your exponent over your index. Okay? So if I have 8 to the 2/3, all right, these two are equivalent. Now, you could use parentheses or not. So say I'm going to put parentheses there. And since 8 is the only thing in the radical symbol, you could choose to square it, which we know the square of 8, but maybe it's a big number that I don't know the square of, or you could take the cube root of it. So the cube root of 8 is 2, so now I just square 2 and my final answer is 4. All right, so when you have to simplify, you should simplify to the furthest answer. Sometimes this is changing from radical form to exponential form. If it's asking for exponential form, you have to write it like this. If it's asking for radical form, you should leave it like this. If it's asking to simplify, you write your final answer. Okay, so remember it's exponent over index, or power over root. All right, let's find these roots. So plus or minus is going to be in our answer. I'm just going to jump ahead. Square root of 25 is 5. Square root of x to the 4th, that's a 4, that's a 2. So it's x to the 4 over 2, which is x squared. This one, since these are in the parentheses, I could leave them like that. So I have 12 over 2. So that is 6. This is not just y to the 12th, 7 to the 6th. This is multiplied 6 times, kind of like Pascal's triangle that we did several lessons ago. Okay, so Do not simplify that by just saying 7 to the 12th. I mean 7 to the 6th, y to the 12th. No, no, no. It'd be this times this times this times this times this times this. Same thing over again. 343, the cube root is 7. 7 squared is 49. 49 times 7 is 343. And then I have a to the 18 over 3 and b to the 6 over 3. So it's a to the 6 and b squared. What they want you to write in here, and maybe it's clearer to you, this is 7 cubed. This is no, 7. There's the cube. A to the 6 cubed, and this is b squared cubed. So when I take the cube root, I get what's inside left. Before I go on to the imaginary answer, similarly to the square root when you simplify, if I have a to the 19 cube root of a to the 19, I know 19 divided by 3, yeah, that would be a 19 over 3. But to way to simplify it in radical form, it's the cube root of a to the 18 times cube root of a to the 1. When you multiply, you could put them both inside the radical form or keep them separate. 18 plus 1 would give me 19. That is in the radical. I'm sorry, I squished it in there. So this is a to the 6th, and this a just stays in there, stays in the radical, okay? If it's asked for exponential form, you'd write a to the 1/3. All right, negative 289. Since it is negative, I take the square root of negative 1 times that, which is I. Square root of 289 is 17. That goes first, then the I. Then square root of c to the 8th, c to the 4th, d to the 2nd. 4 divided by 2. All right, let's look at these and where the plus and minus are. Well, the minus. This one's outside, outside, inside. So whenever you have inside, you're going to have an imaginary number. Square root of 196 is 14. So I have 14i, which is the square root of this part, and then x squared. This one is negative 14x squared. This one is plus or minus 14x squared. No I on these, but imaginary here. All right. When you find an even root of an even power, the result is an odd power. You must use absolute value of the result to ensure the answer is not negative. So when you have an even power, you have the plus and minus, or you could use absolute value, because absolute value, if I say the absolute value negative 17, I get 17. Absolute value 25 is 25. So you always get a positive answer. So instead of saying plus or minus 3x, you could just say it's always going to be positive. This number cannot be negative. When you're doing work for me, I do not mind this. Okay. All right, let's go on to rational exponents. So this is the guy that invented the radical symbol. And if you, because the small r is like radix. And if you use the radical symbol in Word or Docs, it's short like that, which I think kind of looks like an R. It is not long like that to include everything in it, but usually it's short like that, and then you would write x plus 2, and that implies this is in the radical. All right. So rational exponents, again, like I said, power over root. I want you to write exponent divided by index, which is the same as power over root. And again, root here is the radical form. So this is a root, this is a root, okay, cube root, square root. They gave some examples, which they did all the way completely. Like I said before, this is exponent form, this is radical form, and your final answer is simplified to 25. So if I have, let's say 3 to the 5 6, that is the sixth root of 3 to the 5th. And you could put parentheses or not. Can't take the sixth root of 3, so this one I'd have to raise to the power of 5 and then take the root. In your calculator, or my calculator, you have this and you could do any root. And then you have this one, which is the square root. So this button, you could take any root. You can also enter 3 and then do the exponent to the 5 6. But for me, for this lesson, I prefer you write it in either form, but don't find the final answer with the calculator because you need to understand where each number comes from. Okay, so here's the example. They already did it. Power over root. Small number, small number. So if I have y to the, I don't know, 4 fifths, fifth is my root, 4 is my power, my exponent. So now writing this in exponential form, x 2 over 5. 5 is smaller, goes on the bottom, the denominator, power is 2. Example 4, I feel they did it completely, so I'm not. Example 5. I'm going to write it over here. Oh, negative exponents. Let's write that over here. Negative exponents. You may already know, but if I have x to the negative 1, it doesn't change the number, but that's 1 over x to the positive 1. This division line, the exponent changes sign when it crosses over. So if I have, I'll say 1 over 2 to the negative 4, that needs to go in the numerator to be positive, that is 2 to the 4. The thing I want you to be clear about is if I have 3y to the negative 2, the 3 is perfectly fine because it has a positive exponent of 1. The 2 is what's negative. So that is a division line. The 3 doesn't go anywhere. The y squared goes to the bottom and becomes positive. This one, I'm going to start it from here. So that's 1 over the 5th root of 32 squared. I don't know what 32 squared is, but I know the 5th root of 32 is 2. So that's 2 squared, or 1/4. Like our other properties, when you multiply same base, you add exponents. And in order to add rational or fractions, you have to get a common denominator, which this case is 6. This one is a negative, so all I would do is move it to the denominator and make it a positive. So I'd stop there. They actually added 1 as a fraction to move it, but that's okay. And this one, we have 3 and 4. Those are not a common denominator, so you need 12. So you have 12 plus 12. So this one's a negative. 3 into 12 is 4, so 1 times 4. This one's 4 into 12 is 3. 3 times 3 is 9. 9 minus 4 is 5. All right, let me know if you have any questions. Your assignment is 2 to 46 evens only, page 319. Thank you.